So solving a right triangle when we have angles and a side, okay, we can solve this triangle. We can let that be x. Okay, I have an angle, I have one side, which means that I can describe this with a ratio, convert this to a ratio. And since I'm going to use the opposite and adjacent is TOA, which is tan. And that's going to give me opposite to adjacent. And using that the tan ratio from my calculator, I can then come up with an equation for this. So my tan ratio is 0.700, and that's always going to be compared to 1. And we can then solve for x. So we get 44 times the 0.700, and I get 30.809, so I'm going to round that to 81 centimeters. We can work out the third side using Pythagoras. I'll call that h, or my hypotenuse. H squared is equal to 44 squared plus the other shorter side squared. Since h is a long side, we're going to add, so 30.81 squared. Okay, so I'm going to end up with h squared approximately equal to 2,885.2, and solving for h, okay, and we're going to be off by a little bit depending on where we rounded and how much we rounded, but my h is 53.71 centimeters. Okay, so once we have those three sides, I'm just left to solve for the other angle. Well, the other angle is complementary, and we can just work that out by subtracting from 90 degrees. So another skill is to be able to solve a right triangle with two known sides. So here I've got two sides. I can solve for the third side using Pythagoras. Okay, so I'm going to call that side x. So I know that x is a shorter side, so I'm going to take the long side squared minus the shorter side squared and square root that. Okay. So I'm going to end up with x squared equals 12.5 squared minus 10 squared. That gives me 56.25. Square rooting both sides of that. I'm going to end up with 7.5. Okay, and again, I'm just going to use the 7.5. So this is the length of 7.5 exactly. This is a Pythagorean triple, so it's exactly 7.5. From here, we want to go from ratio to angle. So if I take a look at my chart here, ratio to angle, I'm going to use the inverse. I'm using the inverse operation. Okay, so my inverse operation, I'm going to solve for that angle A. So I know I'm going to use here the two sides that were given to me. So that's going to be adjacent and hypotenuse. And that's cosine, ka. So adjacent and hypotenuse. Okay, so I need to do the opposite to find the angle A. So I'm going to use the inverse operation cosine. So my input is my ratio. I'm going to end up with an angle from this ratio. So 10 divided by 12.5. The inverse cosine gives me an angle of 36.869. So I'm going to round that to 87 degrees. And then subtracting from 90 degrees is going to give me the other angle in here. This is 53.13 degrees. Okay, so there I've solved my triangle. So the other thing that I need to be able to do is finding parts from composite figures. Okay, so when we have pieces like this, here we're being asked to solve for the angle here. And we have to figure out lengths of pieces, and we have to focus on the fact that we need a right triangle. So I need to work with this right triangle. which means I need two sides. Okay, so I have one side, the hypotenuse, and because of the symmetry of this diagram, I know that the base can be divided into two equal parts, so that's 10 and 10, and I can transfer that 10 to this side. So working out the angle then, it's going to be adjacent in hypotenuse, which is ka, so cosine of angle A is going to give me adjacent to hypotenuse ratio. Okay, so I need to undo this to get my angle. So I need my calculator to do this. So again, I'm going to do inverse cosine, and 10 divided by 14. And that gives me an angle of 44. It's pretty close to 45 degrees, 44.415. So I'm going to round that to 42 degrees. Okay, so we have to be able to transfer pieces and figure out unknown pieces in composite figures by just translating pieces or kind of working out unknown pieces. Okay, so there it is. There's my angle that I needed to solve for.